Hello everyone, here is the answers to the Unit 10 exercises. In the first exercise, you're asked to prepare a depreciation table using a new method of depreciation to you called the sum of the year's digits method. So what we have here is that on January 1st, 2018, Screaming Trees Logging Company is going to purchase a generator for $200,000. That is our historical cost. They're estimating that the useful life of this asset is going to be 10 years and that it has a residual value of $50,000. So what do we have to do for the sum of the year's digits method? Well, the first thing you need to do is you need to find what your useful life is. Our useful life is 10 years. And then to figure out what your sum of the year's digits method is, you add up all of the years. Like literally, it's 10-year assets. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 equals 55. We're going to have a depreciation fraction in our table, and the sum of the year's digits is always going to be the denominator in your depreciation fraction. Start by filling in our table. We're going to start with 2018. Our depreciation base is the difference between our historical cost and our residual value. It has a $200,000 historical cost. We think that this generator is going to be worth $50,000 at the end of its useful life, which means we need to decrease its value by $150,000 over its useful life. How much are we going to depreciate in the first year? We're going to depreciate it by our depreciation fraction, where the numerator is how much life this asset has left, and the denominator is the sum of the year's digits. Well, it's a 10-year useful life. So our numerator is going to be 10. We already figured out our sum of the year's digits is going to be 55, which means if we multiply our depreciation base by 10/55, we get the first year's portion of depreciation. And that's going to be $27,273 rounded off to the nearest dollar. Accumulated depreciation is always just the sum of all depreciation expenses. Since that was the first year, we've accumulated $27,273 of depreciation on this asset. And then for our book value, we take our historical cost of $200,000 and we subtract out our accumulated depreciation of $27,273. And at the end of 2018, this generator will be on our books for $172,727 book value. Moving on to 2019, well, the depreciation base does not change year to year in the sum of year's digits. We're still depreciating by $150,000 over the asset's life. What's our fraction going to be? The denominator never changes. The sum of the year's digits is always going to be 55 throughout this table, but how much life is going to be remaining will change each and every year. It was a 10-year asset. We used it for 2018, so when 2019 rolls around, we have 9 years of useful life left. So we're going to multiply that depreciation base by 9/55 to come up with a depreciation expense in year 2, 2019, of $24,545. We add that to our existing accumulated depreciation, and we're up to $51,818 in depreciation on this asset. When we subtract that $51,818 worth of accumulated depreciation from our historical cost of $200,000, the book value of this generator at the end of 2019 will be $148,182. Moving on to 2020, depreciation base is still $150,000. We have 8 years of useful life left, which means we're going to multiply by 8/55. Depreciation expense would be $21,818, increasing our accumulated depreciation to $73,636 and decreasing our book value to $126,364. Year 4, 2021, depreciation base has not changed. There's 7 years of remaining life, so our depreciation fraction for this year is going to be 7/55. We multiply that by our depreciation base to arrive at a depreciation expense in 2021 of $19,091. Increases our accumulated depreciation to $92,727, and our book value at the end of the year is going to be $107,273. And we are just going to repeat this process over and over again each year, reducing the numerator of our depreciation fraction by 1 to account for the year of remaining life that is gone now that we've used it. Over and over and over again for this big gigantic table. We're going to keep going on until at the end of this table, our book value at the end of the year is going to be equal to the salvage value. So 2027 was the last year of our 10 years of useful life. We ended up with a book value at the end of the year of $50,000, which is exactly equal to our residual value. Sum of the year's digits is an accelerated form of depreciation. As you can see from the depreciation expense column, we're going to depreciate this asset more and more in the first years that we use it, and each year the depreciation expense we record on it is going to get smaller and smaller. So this is a useful depreciation tool for an asset that's going to lose more value up front. In this case, we have a generator. Well, new models of generator come out all the time. It's entirely possible that this is going to get superseded by a better model of generator. So like anything technology based, we think it's going to lose more value in the first few years than it will in the later years. We choose an accelerated depreciation method. Double declining might be a little extreme, so let's use something that's not quite as extreme, and that is the sum of the year's digits method. In exercise 2, it's the same concept. It's still sum of the year's digits, but now we're not putting the asset on the books on January 1st. We're putting it on the books on June 30th. In this one, Tulips and Teardrops is buying a delivery truck for $60,000. They think it's going to have a useful life of 6 years, and at the end of its useful life, it'll have a residual value of $10,000. Let's prepare a depreciation table using the sum of the year's digits method, but this time we're going to have fractional or partial years. First year that we have is going to be 2018. Our depreciation base is our historical cost, which is $60,000, minus our $10,000 residual, $50,000 depreciation base. Our depreciation fraction, first let's figure out our denominator, the sum of the year's digits. To get there, you figure out how many years are in the useful life, and you add up numbers until you get to that number. It has a 6-year useful life. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 equals 21. This is a 6-year asset, so at the time that we start using this on June 30th, 2018, or July 1st, 2018, if we start the next day, it's going to have a full 6 years left over our sum of the year's digits of 21. When we multiply our depreciation base by our depreciation fraction, in 2018, we're going to record $14,286 worth of depreciation. But we're really not going to. Why? Because we didn't start using it until the middle of the year. It was June 30th when we bought and put this asset into use. That $14,286 is the annual depreciation. It's for the entire year. So we're not going to record all of that. We're only going to record half of it because there's only half of the year left. Which means our current year depreciation, which is our annual depreciation multiplied by the portion of the year that's left, is going to be $7,143. So that's how much we're going to actually depreciate by, how much accumulated depreciation we're going to have, and we're going to take our historical cost of $60,000, subtract out our accumulated depreciation of $7,143, and come up with a book value at the end of the year for this particular delivery truck of $52,857. In 2019, we're going to have the same depreciation base. What is the remaining life of our asset? Well, there's different ways to go about this, but I found the easiest one to think about it is this way. It's a 6-year asset. In 2018, we used it for half of the year, which means why not just have our fraction be 5.5 years remaining over 21? Since we only used it for half of a year, we're not going to use 5 because we haven't used a whole year's worth of depreciation on this asset. So at the beginning of 2019, there is 5.5 years left. So make that our numerator, use 5.5 over 21 as our depreciation fraction, multiply it by our depreciation base of $50,000, and we get annual depreciation of $13,095. We don't have to worry about the partial year because we're using it for the all of 2019. So let's just add that annual depreciation expenditure to our existing accumulated depreciation, increasing the depreciation on this delivery truck to $20,238. And by doing so, we're going to lower the book value to $39,762. In 2020, the depreciation base is still $50,000. Well, now we've used it from June 30th, 2018 until January 1st, 2020. That is a year and a half. It was a 6-year asset. It means we have 4.5 years of useful life remaining. If we multiply that depreciation fraction of 4.5 over 21 times our depreciation base of $50,000, we get $10,714 as our annual depreciation. Add it to our existing accumulated depreciation to increase its value to $30,952. and reduce the book value of its delivery truck to $29,048. And we're going to continue to do the same thing year after year. The only difference being we're reducing the numerator of our depreciation fraction by 1 to account for that year's worth of usage and decrease its remaining life. So as we do this, going down, we see that each year our annual depreciation is decreasing. And since this is accelerated depreciation, that should be the case always. If you have a number that is not lower than the year before it for annual depreciation, you got something wrong. But in 2024, when this year rolls around, our depreciation base will be $50,000. What's left? Half of a year. So we multiply by 0.5 over 21 to come up with annual depreciation of $1,090, increasing our accumulated depreciation to $50,000 and reducing our book value down to $10,000, which again is equal to our residual value.